Motherboards are made up of thousands of tiny traces and solder connections. Attached to these connections are many high-density electronic components packaged in ball grid array, or BGA format. These components include the chipset devices and LGA processor sockets. If any of the hundreds, even thousands of the solder joints between the motherboard and component are defective or the component is defective, it will need to be removed and replaced with a new one. Intel has developed the processes to remove and replace these components with a high success rate. These guidelines include developing the proper thermal profile for automated removal and installation of BGA components, the correct board cleaning, and new component preparation methods. Differing from board assembly, board rework typically uses a hot air rework station. Guided by a thermal profile, the rework station is able to provide localized heat to the target component. The thermal profile specifies the relationship of temperature over time produced by the rework machine. A proper thermal profile will include 4 steps. The first step is preheating the board. The goal is to bring up the ambient temperature of the board and get the joints in the 125 to 150 degrees Celsius range. Step 2 is the soak stage. With the nozzle down, the temperature at the BGA joint should be increased to the 200 to 220 degrees Celsius range and the socket joints to the 190 to 215 degrees Celsius range. The third step is the peak reflow stage. With the nozzle down, this will hold the temperature in the peak reflow range above 217 degrees Celsius for the time specified. Step 4 is the cool down step. With the nozzle raised, the board is brought down to between 100 and 130 degrees to perform the motherboard site dressing. To create the correct thermal profile for board rework, a profile board needs to be made. To measure solder joint temperatures, thermal couple sensors are mounted to the bottom of the motherboard by drilling through the board into the solder joints. To measure component body temperatures, the thermal couple sensors are mounted to the component. Another should be mounted to the pick-and-place cap and any vent holes covered. The location of the thermal sensors is key to capturing the true temperatures the component experiences throughout the thermal cycle. As an example, for a socket B component, the sensor should be mounted to the 4 outside corners and 2 inner corners. This is a graph of a successful thermal profile. The data from the thermal sensors are tightly grouped throughout the thermal cycle. It also shows the performance of the bottom heater, which controls the board heat, and the top heater, which localizes heat to the target component. Once a successful thermal profile is developed, it can be used for BGA component removal. First, be sure to use the proper support configuration under the target component. In this case, these 4 pins support the socket area. Before removing a socket, secure the pick-and-place cap with Kapton tape. Then mount the motherboard securely in place and follow the machine instructions and prompts to remove the BGA component. During the BGA component removal, there will be small bits of leftover solder on the motherboard. Before installing the new BGA component, this solder will need to be wicked off and the area cleaned. To dress the site, the following tools are needed: a soldering iron, 10 mm heating tip, wicking tape, flux pen, wire cutters, isopropyl alcohol or IPA, lint-free wiping cloths, and a microscope. To wick the solder, first apply flux to the pads to be cleaned with a soft, lubricated brush. A stiff brush runs the risk of lifting or cratering the pads. Make sure the soldering iron is up to temperature. Then apply flux to a clean portion of wicking tape and place it just off the edge of the pads to be wicked. Place the solder tip on the wicking tape. Hold it in place for 2 to 3 seconds to bring the tape up to temperature. Then use the iron to draw the wicking tape across the pads. Only go in one direction, and after each pass, trim the used wicking tape and apply more flux to the new tape section for each consecutive pass. It's heat that wicks the solder, not pressure, so only a light touch is needed. The speed the iron is passed over the pads is also critical. Too quickly and the solder may stick, lifting a pad. Too slowly may overheat the pads and cause brittleness and may lift pads. The total contact time should be around 6 or 7 seconds per stroke. Once the entire area has been wicked, thoroughly wipe and clean it with IPA and clean wipes. Inspect the area for any missed pads or damage. To prepare the new component for installation, soldering paste needs to be printed onto the solder balls. The tools needed are squeegees of various sizes, solder paste, and a printing station or jig. On the printing stencil, oval apertures are preferred over round ones because the oval openings keep the stencil high on the ball, resulting in the solder paste being mainly deposited on the tip of the ball. Begin the process by placing a new component into the printing jig. Carefully align all the balls with the openings on the jig. This can be done by hand and close inspection or an alignment jig. With the component in place it down with the component up and install the clamping frame to hold it securely in place. Once the component is secured, flip it over to check the alignment and expose the printing stencil. With the solder paste in a small container, use a small squeegee to stir the paste until it's smooth and workable. Gloves are recommended when working with solder paste. Once the solder paste is a good consistency, spread a line of paste along one edge of the stencil openings. With the larger squeegee, spread the paste to cover the entire stencil surface. With all the apertures covered with paste, pull the squeegee over the surface, pressing down the blade at a 45-degree angle, forcing the paste into the openings and onto the balls. Remove the excess paste from the stencil. A good printing should look similar to this. To install the new component on the prepared motherboard, place the board on the rework machine bed. Firmly clamp it down and apply flux to the area. Apply it in perpendicular strokes to ensure complete coverage. Place the new component on the installation table. When prompted, remove the jig clamping component, align the socket to the motherboard, and let the machine go through the same thermal profile to install the new component. The process described here is mainly for desktop motherboard rework, but the same principles apply to server and mobile boards, which may use different component local supports underneath the board and may demand more careful treatment for finer pitch ball grid array and its footprint pads on the board. The key to a successful BGA rework is generating a capable thermal profile. Ensuring that the board is cleaned and dressed without damaging the solder pads, and properly applying flux and paste to the new components.